I'm Ray, and yeah, I'm going to talk about Theano today. And generally speaking, Theano is a symbolic computation package, which provides some very useful tools to build deep neural network. So a lot of people are currently using it. And there are several advantages of Theano, and the first one is that it really had a lot of details to the users. You don't really need to worry about the data transportation between CPU and GPU. You don't need to worry about how to implement the NVCC code on the GPU. You just focus on the building of the structure of the neural network, and Theano will automatically do all of the optimization for you. So it's pretty awesome. And also, another advantage of Theano is that it really doesn't require so many dependencies. Well, the only tricky dependency is the NumPy, I think. So it made it really easy to install Theano on a server where you don't have a root privilege, but still you can easily install Theano. If time allows, maybe I will talk about the installation of Theano on SharkNet at last. But for now, let's just begin. Just like I said before, Theano is a symbolic computation package, and you can see the thing here. You define a symbolic variable.
Could you increase the size?
Okay, I tried, but
Do Command plus. That's good.
is it good enough? Okay.
Even a bit more.
Okay.
Yeah, great.
Yeah. Oh, so yeah, I forgot to mention it. These codes are directly from the Theano tutorial. Yeah, that's probably the biggest advantage of Theano. It has really good documentation, and I really recommend you to go through that. And so, yeah, this is we define a symbolic variable here, and then we can do the computations. We assign this value to S. This S may be kind of a formula of X. And one tricky thing here is that because X is a special class, a symbolic variable class that's defined by Theano, so you can't use the built-in functions of Python, like ESP, lot, or square root, those kind of things. You must use the versions that are provided in the Theano package. So this way, you can define a formula of X, and then you can use the function Theano.function to evaluate the value of the formula. So basically, this sentence just made the variable Logistic a function. And this function takes an input, and it transfers the input to X. It just considers the input as the value of X, and based on that, compute the output S, and return the value of S based on the formula. So you can see when you input a matrix, that's what you expect to get. It's just element-wise logistic function. So here is another example. You define two matrices, which are symbolic matrices. You define the formula difference, absolute difference, and difference squared. So you can see here, the Theano function, it can take multiple input, and it can generate multiple output. So when you assign values to this function, it takes this matrix to A, and this matrix to B, and you get the result that we expected. This thing is a diff, this thing is the absolute difference, and this matrix is a difference square. Yeah, that's basically the Theano function. And also, you can give a default value to the symbolic variables. Use the param function in this here. So you can give y a default value 1 in the Theano function, and it just acts like this. It's pretty self-explained. And also, you can give it a name. So when you assign values, you can assign it by the name you give it. It's yeah. And also, another special data type in Theano is called the shared variables. And it's kind of a hybrid of symbolic and non-symbolic variables. You know, you can use the shared variable in a formula, just like you're using a symbolic variable. But also, the shared variables, they have internal values from the beginning. You know, they're not. That's the difference between shared variables and the symbolic variables. They always have a value. And you can always use the method .getValue to get the internal value of the shared variables. So in the Theano tutorial, they explain why they design this special class, because they think this way they can update the value of the shared variables more efficiently. And also it's something to do about the data transportation between the CPU and GPU. So they define this special class. And you can see the special thing about the shared variables is that you can use the updates option in the Theano function. And so this way, the function accumulator just works like it takes the input as the value of this symbolic variable, and the output is the value of state. And whenever accumulator was called, it automatically updates the value of state by increasing it by the number, the value of int. So you can see this is the result. Okay, move it through. You first call this function with the input 1. You generate the value of state at this time is 0. And the second time you call it, the value of state becomes 1 because it updates last time. And yeah, so this is how it works. And also, sometimes you use shared variables in a formula, but you don't want to use the original, the internal value that it has. You want to just give it another value. You can use this option in the Theano function. And this just works like, just in this function, it gives state another value. But it doesn't change the state, the shared variable's internal value, but just treat this thing as another value, only in this function. Yes, and the good thing about the symbolic expressions is that it makes it really easy to compute the gradient. You know, in Theano, the computation of gradient is just use this function. It automatically computes the gradient. And just like it shows here, yeah, you input 4, you got output 8, and yeah, it's exactly what we expected for the gradient. So with this in mind, we can move to a example, logistic regression. It's, but here they use gradient descent to train the logistic regression. So you can basically think of it as a softmax layer. At last, it can be seen as actually a neural network without a hidden layer. So first we generate the data. The data is totally, including the labels, the data is totally generated randomly. And then we define the symbolic variables for the data and the label. And then we define the weights, W and B. And we really need to define the weight in the shared variables. It's common practice because only in this way the Theano can transport the things into your GPU's memory. And so after that, we can define the cost function. Here, you use cross entropy, and it's just negative log likelihood. And then the cost function is just negative log likelihood, the average negative log likelihood, and plus L2 norm. So after that, you just use this function to compute the gradient of your toss function with respect to your weight. Yeah, it's pretty easy. And then you define the Theano function here. So basically, this is the function you use to train the weight. You see, you just take input, and your output is the loss and the prediction. And along the way, it updates the weight by the thing's learning rate multiplied the gradient. It's really easy. So basically, when you train, you just write a loop, a for loop here. You call the function train many times, and it updates the weights many times, and it finished the training. So it's like the output of the weight. And yes, this is randomly generated labels and the prediction that we get after so many rounds of loop. But it's just totally overfit because the labels are just generated randomly. It has no any internal things here. So after this, I highly recommend you to go through this tutorial. It's also a documentation of the Theano package about implementing convolutional neural networks. This tutorial, they have really detailed comments on it. So I think I just don't go through it. It's a lot of comments explain what they are doing, and yeah, I highly recommend you to go through that because that's kind of the framework of implementing convolutional neural networks. And you just make small modifications, change some lines, you can implement a different structure on different data set. So yeah, basically that's wait a minute. Basically, that's the grammar of Theano, and as you can see, it's pretty easy. But there are still some people who think that this is maybe not easy enough, and they developed several packages based on top of the Theano. Well, the two most used ones are, I believe, the Lasagne and Keras. And our classmate Dylan is going to introduce Keras later. So I just quickly go through the package Lasagne. So yeah, this is a function defined for loading the data. And so in Lasagne, it really made building a network just like play the Lego, the building blocks. You first define an input layer, and next you define a convolutional layer. Just take the output of the input layer as an input, and then you define the pooling layer, then a convolutional layer. And yeah, it's just one by one layers, and then that's the definition of a convolutional neural network. It's very easy. And here is a function to generate the mini batches, and that's not the part. Yeah, and in training, you just use the function we defined before, the building the network, and then you define the loss function, predict function, and they offer the tools to get all of the parameters from all of the layers of the network. And yeah, they give you different choice of the way you do gradient descent. And here is a Nesterov momentum, but there are plenty of choice in the update module. And yes, and also there are different choice of the objective function. Here they use cross entropy, but there are also other objective functions in the objective modules. And when training, you just define a train function, which takes the input data and target data. It outputs the loss and do the updates. So in Lasagne, it's really, really simple to to define a convolutional neural network. And yeah, here's just like the output. And also, I'm going to show you an example of the recurrent neural network. It's also in Lasagne. Yes, here I just use the S&P 500 data, and it's just like 5 dimension. Each day is, I believe, open price, close price, highest price, lowest price, and the turnover volume. And generate the labels based on the tomorrow's price, whether it's higher than today's close price or not. And of course, this thing doesn't make any sense. In the history data is just not strong enough to predict tomorrow's price because so many things can happen at night, such as Turkey take down a Russian plane, these things. So, but anyway, it's just to show you the way to implement recurrent neural network in Lasagne. So again, it's very simple. You define the input layer. The tricky thing here is the shape. In Lasagne, when you do recurrent neural network, it requires the input data to have this shape, batch size, match sequence length, number of features. So I suppose it can't take arbitrary long sequence. You have to define a maximum sequence length. And then after the input layer, you just define the recurrent layer. And then it's just, you can have different ways to set the initial values to the weight and also an output layer. So that's just the structure of the recurrent neural network. And yes, still the training process is still the same. You just define the train function, which implements the update, and you just train the network by calling the train function many times. And as you can see, it really doesn't make any sense on the data. And yeah, I trained too many loops. And yeah, you can actually, you can build a strategy based on the prediction, but yeah, it doesn't make any sense. But I think it's not the method's problem. I think it's, you need to have maybe high frequency data if you want to implement the machine learning stuff in the trading. You really need high frequency data, and you need maybe the orders at the price at around the current price. That's maybe the most powerful data to do the prediction of the price of stock. So yeah, that's it. That's pretty what I want to talk about this part. And also maybe just a few tips about install Theano on ShardNet. The thing is that on ShardNet, they have already installed a version of Theano, but that is too old. And if you want to install Lasagne always requires the latest version of Theano. So basically, you just need to install Theano again. And the thing is that when you install Theano, as I mentioned before, you need to install NumPy first. And usually when we install Python packages, we use the PIP tools. But I think that doesn't work on ShardNet when you, you can't install NumPy by the PIP command. There is something wrong about the GCC, I think. And even if you, okay?
I think you can, but you have to specify for your home directory.
Yeah, I know that, the -- user, yeah, I know, but that's not my problem. That's not the error message I get. It's something about the GCC. And also, even if you install that, the NumPy you installed through PIP, it has a large chance that it can't link to the correct BLAS package. Because on ShardNet, the BLAS package is not stored in the default place is some strange path. And so basically, you need to manually download the BLAS package, and you compile the NumPy from its source code. I believe that's how I do it. And then you can install the Theano and Lasagne. There are some posts about how to do that on the Stack Overflow. Maybe I can copy that to the Piazza. And if you have any questions about installation, we can discuss it maybe on Piazza. It takes me a long time to set everything down, but it's really not that difficult, I suppose. That's pretty much all I want to talk about now. So is there any questions? No? Okay, so maybe we can move on.